Good day once again. I am Relwan Mikael by name. Here we are today into Scia Engineer 15. I want to design a telecommunication mast of segment 3.5 meters up to 28 segments, which is 98 meters. When you set 3.5 times 28, it will give you 95. So this is Scia Engineer. This is how the software is. When we are starting our project, we will start with new project. We are into analysis. We double click on analysis. So this is the first settings of the project which we are going to do. Now the name of the project is we can call it analysis. Sorry, gather structural. Then it's part 1. Description, analysis, and design. The author, engineer Ogun. Slash So this is the software. We are filling in information that will be required on the calculation at the end of the work. So we are designing for steel. We'll select steel grade. We change it to the grade we want to use. So we are using PS code. We have different codes. You can select codes here. You can add. There are different codes. So we are using PS as we have already. So this is the structure. We are designing the structure at XYZ coordinates. The solver is Nevis. We have Scia Engineer Nevis. Can you see Scia Engineer solver? The model is one model. Consolidate. Then we have functionality. We are going for dynamics. The steel. We are going for internal stress. We have the climatic loads, the stability, and structural model. We have parameters, the GA, our checks, and we have our documentation. So we are clicking for the dynamics and general dynamics, connection mono drawings. We have our checks and expert system. So these are what we are going to do. Then we have our loadings. The wind load, we have to generate the engine. We have to use the user curve, the type, the BS and the EN, Euro code and BS code, parameters of the pressure. If you can see, per meter square. Then we OK it. This is the curve that it will be used for determination of the curve, the wind. So we close. You see the values, the figures of the wind pressure. Then we have to apply the snow load, which is according to the code is 1 kilonewton per meter square. Then you OK it. Then it will the environment of the Scia Engineer will open. After opening, we will start by creating the sections that we'll be using. So we have three members for our design. You come to the library, you come to your cross section. This is our cross section. We have already defined material as cross section. We are going to add our cross section. We are going to use CHS this. So the area of concern for the design is we are going to subject this tower for analysis. Already it has been designed, but they want us to check the forces on the structural elements. So they have already sections that they have proposed. So this 88.95, they propose it as the diagonal. So we'll add it and name it as diagonal. We'll name it as diagonal. Diagonal. Then we OK it. Then we have another section that they name it as horizontal, which is 144.3 by 5. That is this. They call it horizontal. We call this horizontal members. Then we add another one, which they give is 406 by 12.5. So 406 by 12.5, they add it as the verticals. The verticals. So this is the three members that we'll be using for the design. So we close it. We can close it now. So we close this. So we'll come to our grids. We want to create it as 3D. Now, since we are creating it as 3D, the interval, we have it 1 meter. It repeats as 2. You enter at X direction. Then at Y direction, we have 1 meter. The same thing as 2. It repeats itself as 2. This is what we have. Then along Z axis, if you can recall, I told you 3.5 meters. So it repeats itself as 28, which when you said 3.5 times 28, it will give you 98 meters, which is the total height of the tower. Now we OK it. This is the grid that we are going to use. You OK this. So this is our grid system for the tower. Then you input 0, you type 0, 0. So you enter it. So this is what we have. Now our grids are ready for modeling. So now for modeling, it is a triangular shape of a tower. You close this. So we are going to put our members. Then we go to structure. Under structure, you go to 1D. Then we take member. So we are starting with verticals. We call this vertical. So under vertical, the type is a column, 100. So we have layers. We have to define layers for each member. So let's call this vertical. So vertical, this is the layer. Then we add new. Sorry, let's correct this. The layer, we call this diagonal. Yes, vertical. go to the next one. We call it there. Go now. We add new. We call the new as horizontal. This is the layer, the color of every member. So we are going for the first one, vertical. We select an OK, so it's on vertical. So this is the cross section of the vertical. We OK it, so we'll just pick from here, from the starting to the end. This is our vertical. We click here, then I can show you, we can do individual and we can copy. So we click here to the last point, this, we click, this is the member. So we can go to the other one, this one, the triangular shape. So the last one, the 98 meters height. So this is what we have. If you can see under reality, this is our member. If we want to see the 3D shape, this is our section. If you can see the CHS, the circular section. So we can off the 3D side. So now we are going to create the horizontal members. We will still come to this. We call it horizontal, and we select the section for the horizontal, then we select the layer for the horizontal, then we OK it. The first thing to do is we pick for this, then we pick from this point to this, we pick from this point to this. So this is our first horizontal. Then we escape, we are modeling, then we go back to this. We have what we call the diagonal. The diagonal is on the the horizontal, we did it under beam. So the diagonal is supposed to be general, and then the layers for the diagonal, then we OK it. So we pick from here to here, and from this intersection to this. So we can rotate our model by this sides. Still we need diagonal here, from here to here, from here to here. So we still rotate. Still rotate from here to here, and from here to here. So if we rotate everything, if you can see, this is our members. We can see our elements in 3D. Look at what we have. Very interesting, as you can see. So now I will before we go further to the other segments, we are going to apply our nodal forces and our dead load, live load, wind load generally before we copy. So what I will advise us, let us go back for the loading. For the loading now, what will happen is we'll close this, we'll create our load cases. This is our load. So the first thing is the load cases. Now the description, the name of our loading. You know, self load is a permanent load. We call this self weight have the dead load. We add. We have the live load. Then we live load, its action is a variable. It do usually change, and the specification, the standard is okay, and the duration, let us pick minimum. So 3D wind. The pressure, we are going to put 3D wind, the action of the wind on the live load. Then we have what we call the live load directions. Wind load also is a type of wind load, is not static. Yes, it's static. We are going to change this to wind but x positive. Add. We have wind minus x direction. We have wind y positive, y direction. We have wind minus y direction. So these are the loadings. The live load, under live load, it just the live load we have, since we have our wind individually that we are going to apply. So these are the definition of the load cases. So we have our load cases. So it has given us a room to apply. If you select self weight, already we have the self weight of it. So the dead load, the finishes, whatever. So we have our line forces. This is our line forces. So if you can see, according to the code, is -1. That is -1 on the acting downward. That is dead direction, acting downward. So this one is acting downward. We apply to this member, and this member. So still we have our dead load again. Now we escape. Under dead load, we need to change the direction. Yes, under the dead load we have the y. Let's start with x direction. The negative. Let's start with the negative. If you select this member, and escape, if you can see, it's acting downward, negative. These are the signs of the loadings. Then we still have the positive, acting upward. Yes, the dead load is acting downward. Then we have the live load. Now the live load also, we have before going to the live load, the dead load, we have the y direction. Also we have the negative, as you can see. We escape it. So still for the y direction, we have the positive sides. We are all adding the conflict data. There is a conflict data. Undo. for the dead load, as you can see, we have this are what we have. Sorry, if I may remember, these are what we have. Initially we have this Z direction acting downward, so still for this member Z direction, because the force is acting downward for the dead load, you have to select Z. This one is acting downward for the Z direction for the dead load. So this is what we are having, and then the life load. Also the life load, same thing. You add, it's acting downward. Also this members, the force is acting downward. So this is what we have. Then we go for the wind. The wind load positive. The wind load, now you know the wind load is the direction of X. We start with negative, but global coordinate system, we select this, we select this, and we select this. Then we escape. Then we select wind negative. No, before, it's like I did not edit. Let me remove the loads. I do not edit the figure according to the BS. So the wind, after changing the direction, this one, it should be minus 0.6. that is the value for the global system. Okay, you select this, and this. Then even the diagonals, you select them. You select, you rotate, you select. These are the winds. So then we go for negative. We have our 0.6. now is positive. The direction still it remains. We select for this, the verticals, and the horizontal, the diagonals too. So then we go for Y direction positive. We add load, we change the direction to Y. So for positive, subjected to loading. Subjected to loading. We have other two diagonals here. That's good. Then we go to Y negative. So Y negative now, negative direction. We change this to negative. We locate, we insert. So this is how we apply the loadings. This is how it works. So we have already applied our loadings. Now we'll go back to our model. We can close and copy these segments. So you are going to copy the diagonals and the verticals. So what you will do, you just highlight downward like this. These are the elements. Then we right click, we say copy. You have a suitable intersection here, you copy. You just be going to segments, yes. Just be, this will make our work fast and faster. So we have to go to those 28 segments of the tour. this is how it works. This is how we model in Scia Engineer. Yes. So we keep on going. I have to come back a little bit. I have another load that I supposed to insert. I have forgotten to insert another load, because if I'm going to insert individually now the point load, it will be much more difficult for me. So I have to use this area. So I have to come back to my load case and come back to my live load. Now under live load, I will come to point force in node. I'll put in node. Now in node, the direction, if you can see, it will be X, Y, and Z. So we have to pick X first. So they have already given us what we are going to put in the notes. So they said is 12 kilonewton. So let us start with the positive X direction on the notes. Then you click this note, as you can see. You click another note here. You click another note here. These are the notes we have. And we have 3 notes. Then let me come back again. Escape. So this is for this direction. We'll go back to the note again. We change this to negative. We still, no, sorry, yes, undo. The nodal force, still the nodal force should be this, but minus 12. No, the global system should be, yes. So you're going to apply here at this node, 12, and at this node. So these are what we have, and we have another node here, another node here, another node here. So these are what we have. So now we can copy our model. We can say copy. So instead of copying 1 1, yes, I'll be copying 5 5, so that we can round it up. So let me highlight everything here. So I want to highlight everything. So ready. I want to select. I don't know what really happened. This one is too much. Let me put 2 here. So we are highlighting now. So we are copying the 5 segments. Copy. So you see us in time, we'll just generate everything. Yes. So you see it's going fast and faster. as you can see, going faster and faster. So we'll just do it in time and go to the next one. So this is, I think, let us leave it like this so that we can round it off. So I'll copy the last one, the last segment, copy it to the others. So this is the last segment. So this is our complete tour. If we want to see it in 3D, this is how it works. So this is perfectly nice. So these are the cross section they use. So we want to analyze this and see the stability of the sections, the forces on members, etc., etc. These are the verticals. These are the vertical members. These are the diagonals, and these are the horizontal. So the next thing to do now is load combination. Under load combination, already we have our load cases. So let us create our load combination. We have our load combination 1, load cases. So we want to create the combination now. So my suggestion now is the first combination, let us have 2 combinations. Let us have this, and let us give it BS serviceability. The coefficients are all 1. We say OK. Then we create the second combination, which we are going to add. Let us delete all. In the second combination, let us add all. But remember, for this we have used 0.6, correct. For this one too, correct. For this one too, correct. For this one too, correct. So for this one, let us use ultimate. No, let us use the serviceability too. Then okay, we have 2 combination, we close. So we have stability. For the stability, let us add all. And for this one, we have 0.6 figure. You correct it. But for this and this, we have 1. So we OK it. So you can see what we have here. You close. So the class results. In the class results, we want everything. We add on. So these are what we have for the class result. So we don't need all these things. Yes, the masses. We need the masses. We have 1. So for the masses, for the self-load is okay. Masses. For the masses, we have on all, we have to in notes masses on beams, linear masses. So this is what we have. We'll just highlight everything. So it has applied the masses, as you can see, on the member entirely. So we close. So masses combination, we add on. Okay, we close. Then we go for our calculation now. We want to calculate, so we can check for the model, The first check is to check the structural data, whether everything is intact, whether we have error. Data checked finish, so I think it's okay. So if the note, we have any conflicts in the notes, let us see so that it can fix it. We want to fix it, so it has fixed almost 81 notes. Good. And the next thing to do is the calculation. This mesh whatever reinforcement, because we are not doing reinforced concrete, so we just go to calculate. So we want to go to calculation. These are the calculation we have. It's either you select all or one. So these are what we want to calculate for linear analysis, model analysis, linear stability. So we're calculating for all. There are no supports. Yes, we did not put support, so we have to come back to structure, and I can view my mass like this. Under structure, as we can see, under structure, I will import my supports. So we're supposed to have the supports here, the toolbars, user defined selections, and there are logos of the supports that are supposed to come out. I don't know what happened, but we're supposed to have it. So before putting the support, I think we can let's go for the masses. Let us remove the masses, close, and structure now. What's happened? The tax toolbar. Good. So we have our supports here. I will just do like this. So my supports here is fixed, the support, and engine beams.